Good day, ladies and gentlemen. In the last class, we were discussing the questions in physics, and we stopped at question number 20. So in this class, we should begin from question 21 as we promised. So we are still discussing the physics. But the question 21 says, what are the charge carriers in semiconductors? What are the charge carriers in semiconductors? A. Electrons and holes. B. Holes only. C. Ion and electrons. And D. Ion and holes. So the answer is option A, electrons and holes. Electrons and holes are the carriers of charges in semiconductor. Electrons are the carriers of negative charges, while holes are the carriers of positive charges. So electrons and holes are the carriers of charges in semiconductors. Option A. Question 2 says, which of the following does not use magnetic effect of current to function? Which of the following does not use magnetic effect of current to function? A. A telephone receiver. B. Lead acid accumulator. C. A moving coil galvanometer. And D. An electric bell. So the answer is B. Lead acid accumulator. Lead acid accumulator does not use magnetic effect of current. Question 23. Question 23 is a calculation. So the question says, if the speed of light in water is 2.26 exponential 8 meter per second, and the velocity of light in air is 3.0 exponential 8 meter per second. The question says calculate the refractive index of water. Refractive index of water. So from this question we are given two data. The first one is speed of light in water, and the second is speed of light in air. So we know refractive index is given by this formula: speed of light in air over speed of light in a medium. So refractive index of a medium is given by speed of light in air over speed of light in that medium. So the medium we are discussing in this question is water. So the refractive index of water will be speed of light in air, and the speed of light in air is given as 3.0 exponential 8 meter per second over speed of light in water. They say it is 2.26 exponential 8 meter per second. So let's see. So 3.0 exponential 8 divided by 2.26 exponential 8. So I have 1.3274, approximately 1.33. So I have 1.32 as the refractive index of water, and that is option A. So my answer to 23 is option A. So next question is question 24. In question 24, a diagram is given. Question 24. So we have two bodies. This one is x and this is y. X is negative, y is positive. In the diagram above, the charges x and y are opposite. What happens when they are in contact? What happens when they are in contact? A. X and y become negatively charged. B. X and y attract each other. C. X and y become positively charged. And D. X and y repel each other. So the answer is B. X and y attract each other. Because x and y are of different charges. X is negative and y is positive. So when they are brought in contact, there is going to be attraction, because unlike charges always attract each other. Had it been the charges are of like charges, had it been this is negative, or this is positive, so we'll have repulsion. Like charges repel, but unlike charges attract. So this is option B. X and y attract each other. Question 25. Question 25 is also a calculation. So the question says, a block of aluminum of mass M is heated electrically by a 25-watt heater. If the temperature rises by 10 degrees Celsius in 5 minutes, calculate the heat capacity of the aluminum. Calculate the heat capacity of aluminum. So let's look at the data. A block of aluminum of mass M. Mass of the aluminum is M kilograms. Is heated electrically by a 25-watt heater. 25 watts, that is the power. It's 25 watts. If the temperature rises by 10 degrees Celsius, change in temperature is 10 degrees Celsius in 5 minutes. Time taken is 5 minutes. So the question says calculate the heat capacity. We are looking for capital C, which is heat capacity. Okay, now the mass is M, the power is 25, change in temperature is 10, and the time taken is 5 minutes. So we need to convert 5 minutes to seconds. So we multiply by 60 so that we have 300 seconds. Now we are looking for heat capacity, and we know the formula for heat capacity is quantity of heat divided by change in temperature. Yes, quantity of heat over change in temperature. Had it been the question says calculate specific heat capacity. Specific heat capacity is small c and is given by quantity of heat divided by mass multiplied by change in temperature. Because specific heat capacity of a body is the quantity of heat required to increase the mass of the body by an increase in temperature. Had it been the question says latent heat. Latent heat is quantity of heat over mass, meaning it is the quantity of heat required to raise the mass of a body without an increase in temperature. But heat capacity only have effect on temperature, so it is the quantity of heat required to raise the temperature without an increase in mass. And we know quantity of heat is the same thing as energy or work done. So in this regard, when we multiply P and T, we have our energy, which is the same thing as Q, over change in temperature. So it means my heat capacity is, my power is 25, multiplied by my time is 300, all divided by change in temperature is 10. So let's see, 25 multiplied by 300 divided by 10. So I have 750 joules per Kelvin. 750 joules per Kelvin. So let's see what option is that. That's option A. So the answer is option A, question 25. So the next question is question 26, which is also a calculation. Question 26. Question 26 says, calculate the temperature of 6 moles of an ideal gas at a pressure of 7.6 exponential 6 Newton per meter squared with a volume of 10 power minus 3 meter cube. Calculate the temperature of 6 moles. Number of moles is 6. 6 moles of an ideal gas at a pressure of, so our pressure is 7.6 exponential 6 Newton per meters squared with a volume of, so the volume is exponential minus 3 meters cube. Okay, the question says calculate the temperature. So we're looking for temperature. And R, which is a constant, is given as 8.3 joules per mole per Kelvin. Okay, now using our ideal gas equation, which says PV is equal to nRT. And from this question we're looking for T. So when I make T subject, I have PV over nR. So my pressure is 7.6 exponential 6. My volume is exponential 3 minus 3 all upon my number of moles is 6 multiplied by my constant is 8.3. Okay, so let's see what we have. 7.6 exponential 6 multiplied by exponential minus 3 divided by 6 divided by 8.3. So I have 152.61. So approximately 153. So let's see. 153 degrees Celsius. That is option B. Sorry, option C. That is option C. So my answer to question 26 is option C. 153 degrees Celsius. Okay, question 27 now. 27 is also a calculation. Question 27. 27, a diagram is given that has 3 capacitors in series. This is 3 microfarads, 3 microfarads, 3 microfarads. So the question says, from the diagram above, the equivalent capacitance of 3 capacitors is, so what's the equivalent capacitance of these 3 capacitors? So now, because they are arranged in series, unlike resistors, capacitance in series is given by this formula. If we want to calculate the total or equivalence capacitance, it's 1 over total capacitance equal to 1 over C1 plus 1 over C2 plus 1 over C3. So meaning my 1 over C total is equal to 1 over 3 plus 1 over 3 plus 1 over 3. My LCM is 3. So this into this is 1 times 1. So I have 1 plus 1 plus 1, which is equal to 3 over 3, which is equal to 1. So my 1 over C total is equal to 1. Therefore, my C total is also equal to 1 microfarads. One will take the inverse, and that is option C. Question 27, the answer is option C. Next question is question 28. 28 is also a calculation. So 28 now. Question 28 says a current of 20 ampere, flows through a cable whose resistance is 5 Newton. Resistance 5 newtons. The question says calculate the electric power dissipated. Calculate the electric power dissipated. So we're looking for electric power. So what formula relates I and R to P? We know that power is equal to I squared times R. And my I is 20, so I have 20 squared multiplied by my resistance is 5. So let's see what we have. 20 squared multiplied by 5. I have 2000 watts, or 2 exponential 3 watts. It's still the same thing. So we are relating to the options. The answer is option A, 2 exponential 3 watts. 28, the answer is A. Okay, next question is question 29, which is not a calculation. They say, which of the following statements is not true about atoms? Which of the following statements is not true about atoms? A. An atom is made up of a nucleus and a number of electrons. B. The mass of an atom is concentrated in the nucleus. C. Atoms of different elements have different atomic weights. And D. Atoms of all elements are identical. Which of the following statements is not true about atoms? A. An atom is made up of nucleus and a number of electrons. Yes, this option is true of atoms, because every atoms have a nucleus, and yes, every atom has a nucleus and electrons. Nucleus is the central part of the atoms where protons and neutrons are found. Then electrons revolve around the atom. They are found on the shell or orbit. So A is true of atoms. B, they say the mass of an atom is concentrated in the nucleus. Yes, because the particles in the nucleus, protons and neutrons, are very heavy compared to the electrons. I think the electrons is 1/1840 unit in mass, but proton and neutron have 1 unit each. So it means the mass of that atom concentrates in the positions where the protons and the neutrons are found, which is the nucleus. So B is also true. C, atoms of different elements have different atomic weights. Of course, atoms of different elements have different mass number, atomic masses, that is atomic weight. But D says atoms of all elements are identical. So this one is not true about atoms, option D. So the answer to 29 is option D. So question 30 is also a calculation. It says the efficiency of a machine is 70%. Question 30. Efficiency of the machine is 70%. They say calculate the work done. We are looking for work done. Calculate work done using the machine to raise a load of 10 kilograms. Load 10 kilograms, which is also the mass, through vertical height of 2.0. The height is 2.0. So our load, which is the same thing as our mass, is 10 kilograms. Our height 2.0 meters. So we are looking for work done. Now, when we use the relation that says efficiency is equal to potential energy, mgh, over work done, multiplied by 100%. So our efficiency is given. We have mass, acceleration due to gravity, of course, is 10. Height is 2. So we are looking for WD. So if I make WD subject, work done will be equal to mgh over efficiency times 100. So this gives us the mass is 10, multiplied by acceleration due to gravity is also 10, height is 2 all over. The efficiency, let me use the other side. So my work done now is equal to, my mass is 10, acceleration due to gravity is also 10, my height is 2, all over, my efficiency is 70, then times 100. So let's see what do we have. This is 10 times 10 times 2 divided by 70 multiplied by 100. So I have 285.7. 285.7 joules. This is my work done. Or approximately 286 joules. 286 joules. So let's look at our options. A is 2000 joules, B 3000 joules, C 1500 joules, and D 1000 joules. So we do not have the right option. So there is no right answer to question 30, but the correct answer should be 286 joules. Our next question is question 31. Question 31 is also a calculation. Question 31. Question 31 says the plates of a 0.5 microfarads. The capacitance is given as 0.5 microfarads on charged capacitor are connected to a 10 volt battery. The plates of a 0.5 microfarads on charged capacitor are connected to a 10 volts battery. So my potential difference is 10 volts. So the question says the charge on the capacitor after a long time is, we are looking for the charge on the capacitor. Okay. Now the formula that relates these three is Q is equal to CV, and our C is 0.5. Our potential difference is 10. So 0.5 times 10, we have 5 microcoulombs. 5 microcoulombs, which is option D. Option D is 5.0 microcoulombs. So this is our answer. So the next question is not calculation. 32. It says a satellite revolving around the Earth is kept on its orbit by A. Centripetal forces only, B. Centrifugal forces only, C. Centripetal and frictional forces, and D. Centripetal and centrifugal forces. So the answer is option D. Yes, a satellite revolving around the Earth is kept on its orbit by these two forces, centripetal force and centrifugal force. Any object that revolves around a circle is kept by two forces. One force is acting towards the center of the circle and the other one is acting away from the center of the circle. So if this object revolves around this circle, there are two forces acting on it. One is acting towards the center, the other one is acting away from the center. The one that is acting towards the center is the centripetal force. Centripetal force. The one that acts away from the circle is centrifugal force. So these are the two forces acting on a body revolving around a circle. Now what happens is, if this centripetal force that is acting towards the center is greater than centrifugal force, it means the body comes to the center of the circle. While if the centrifugal force is the one that is greater than the centripetal force, the body goes away from the circle. So to keep this body in a particular orbit around the circle, the centripetal force has to be equal to the centrifugal force, and this is why the body keeps revolving around the circle in a particular orbit or specific orbit. So these are the two forces acting on a body around the circle. So our answer is option D, centripetal and centrifugal forces. Question 33 is also a calculation. What force has to be exerted on a mass 60 kilograms? What force? We are looking for force on a mass 60 kilograms to give it an acceleration of 10 meters per second squared to give it acceleration of 10 meters per second squared vertically upwards. So this body is moving vertically upwards. So if it is moving vertically upwards and we're looking for the force that will give it acceleration of 10 meters per second, so our formula will be equal to mass times this acceleration plus acceleration due to gravity. Yes, because it is moving away from the gravity, it is moving up. So we have to multiply the acceleration due to gravity to give us the force. Meaning the force will be higher when it is going up. So our force will be equal to the mass is 60 multiplied by our acceleration is 10, due to gravity is also 10. So I have 60 multiplied by 20, which is 1200 joules. Yes, when the body is moving upwards, the force is given by mass multiplied by the summation of the two accelerations. But had it been the body is moving downwards, then my force will be equal to mass multiplied by the acceleration minus acceleration due to gravity. Minus acceleration due to gravity. But because they say it is moving upwards, so we use this formula, and our answer is 1200 joules. Sorry, newtons is force. 1200 newtons. So 33, the answer is option B. Option B. Question 34. They say a satellite moves in a circular orbit of radius 4r. They say radius 4 capital R. Of course, this capital R is the radius of the Earth. They say the acceleration of the satellite in terms of g. Acceleration in terms of g is what? The satellite moves in a circular orbit of radius 4r around the Earth. The acceleration of the satellite in terms of small g, that is acceleration due to gravity, is, so our fraction here is 4, or our multiple is 4. So if I want to know the acceleration of this body in relation to acceleration due to gravity, I'll just divide my acceleration due to gravity by the multiple of the radius of the Earth. So it will be g over 4, which is option B. G over 4. Question 35 is also a calculation. Question 35 says calculate the inductance of a coil. Calculate the inductance, which is capital L, of a coil. Calculate the inductance of a coil of resistance 30 ohms. Resistance is 30 ohms connected to a 100 volt AC, meaning my potential difference is 100 volts. Connected to a 100 volt AC source, if the coil draws an RMS current of 2 ampere, my RMS current is 2 ampere. So we're looking for inductance. So the formula that relates this, we have our inductive resistance, which is equal to